actually just this one in the beginning. Yeah, this is sort of where I stopped on regular programming topics. We're going to continue a bit from that with a little bit about Boolean variables and logic, which is a natural extension of writing expressions. Now these expressions, as you see here, these example expressions, this is something even if you don't really program a lot or haven't programmed a lot, then you recognize this kind of stuff from school math. It's so you can write any kind of expression, and it's usually the same way as you do on a piece of paper for a math assignment, and the computer can calculate the result of that expression based on numbers in there and variables. So for instance, these small examples here, I mean, put the first one just to remind you that, just a number, that is an expression to the computer. So expression can be just a very small thing, and it can be a very big thing, but in the end it has a result. And all these expressions here, they have an integer number result. So when you calculate it, then you get the result. And of course the result of 20 is 20, that's logical, but it's just to say that you can use it in the same place as you put expressions. More complicated expressions, you usually just put numbers maybe if you know it's a constant value. But then you see you can use variables like x plus 10, so whatever the value of x is, read from memory, added 10, that will be the result. And more intricate ones with parentheses, so you can, and the parentheses are really these round parentheses, and they are really just like a regular math task. Should be careful using parentheses because these operators, these multiplication operators, plus minus, that kind of thing, they all have preferences. So if you don't put parentheses, then it can be hard to figure out which one gets calculated first. Like, it's the way you expect, like multiplication has higher preference than plus minus, just like when you write math. And that's actually used, like for instance here, this multiplication will be done first and then 4 will be added, because the plus has lower preference than the multiplication. It's exactly the same as write like a math assignment. So there are two kinds of statement where we can use expressions, and that's assignment and the function call. Two main places we use them anyway. This is a little bit tricky, this one, because this is actually an assignment equals operator. So when we later look at logical expressions, then have this equal operator, which is something else. So if it's 1 equal, then it's not an operator like plus minus. It's a operation we do. So we calculate the result of this expression and then assign it to this variable. That's what it does. The other one is a function call, and that can have any kind of name, because functions is something that you can define or they can be defined in the system. So for instance here, line is a built-in function in processing, and the way you can see the function call is by these parentheses here. So we have the name of the function and then these parentheses. If there are no parameters, there can be no parameters to a function call, then you just have parentheses, parentheses. That's also a function call. The line function takes 4 parameters. So x1, y1, x2, y2. And in each of these places you can put, the compiler expects an expression. So again, remember that the 0, that's actually an expression. It's a very small expression which only returns 0, but that is an expression to the computer. And then you can do some more intricate stuff here, like put a whole expression. You can put as long an expression as you like. But it may be not a good idea to do that, because it can be very difficult to read the code afterwards. So it's very long, you probably have to split it into multiple lines. But it's just to say that you can combine it in any way you want. Yeah. So, the next topic is what we call Boolean expressions. That's kind of a simpler kind of expression. In sort of computer terms, it's actually it's just what we call a different data type. So before you had expressions that all returned integer values like numbers. So the result was some number, some whole number. So this Boolean type, that is the simplest possible type you can have. It can only have two values, true or false. So we write it in exactly the same way. We use usually slightly different operators because it's different, but the principle is exactly the same. And we use that, I will show you later, we use it primarily for stuff like branching. So that's sort of the main use of it. And as I said, there are special operators, and the normal operators don't usually apply, like plus and minus and multiplication don't apply to Booleans. There are different ones that we use instead. That's a bit big. Yeah. So we have like greater than, less than, and these variations, greater than or equal to. And this special one, this just means equal to. So in school math, remember you write one equal. In programming you write two equal signs. Otherwise it's an assignment. That's something completely different. And this one means not equal to. I'll just put a few examples. This. These are all Boolean expressions. Oops. And again, these x, y, z, those are names of variables. And you can use them in any place. So, I mean, what's in here, that's actually a sub-expression. You can say that's also an x, that's an expression, right? So that returns like a whole number. 20, that's also an expression. So you put two expressions here, and then the result is a Boolean value. It's not a whole number. The result of the greater than test is just, is it greater than or not? True or false? Okay, save that. Yeah, so I did start a little last time talking about loops, but there is a simpler kind of branching. You could say simpler, but it's a different kind of branching, the most basic kind of branching that can happen in a program, where the program decides which way to go. That's what we call branching, and that's what we call a conditional branch, or if then else. Conditional branching. So in processing code, or also in Java code, we write this if something, and then these curly brackets, like that. And in here we put something. Actually, a different color for that. I don't know why. I just did. We put some red stuff, and in here we put some yellow stuff. And the red stuff, if something that is, do you know what that is? Yeah, it's a Boolean expression. That was the word I was looking for, but it's the condition, you could say. So this, all the stuff from the previous slide, Boolean expressions, you want to put something, a Boolean expression of some kind in the if. So a very simple Boolean expression, the simplest possible, is like if true. That will be valid. You can write that because true is a Boolean value, and that's actually an expression that is constant value. So if true would be okay to write in a program. It's not very useful because you could just omit it altogether. But usually you would write use one of the
false has its uses.
If false. Yeah, I mean for like you're debugging code and want to switch it off, stuff like that. So I'm just gonna actually put those here. Just to give you an example. So something like that, you could put that here. And of course the yellow stuff is the code that gets executed if the Boolean expression happens to be true. What happens in terms of the program flow is, like we can sort of draw the program flow like a, oh, it's a bit crooked. Like, you remember that when you have a piece of code, then when the computer executes it, it starts from the top and executes one statement at a time, just goes downward. And this is what this arrow symbolizes. But in fact, if we have an if, then we have what we call a branching point. So it's a point where the computer can do two different things. It can either continue or it can do a jump. So the jump we can show like this. So it may skip the yellow stuff. Branch point. And it's maybe kind of self-evident, but depending on the value of the expression, it either continues. If it's true, it continues. If it's false, it skips the yellow stuff. There are a few more things we can do. Other forms. That is the else. If something, curly bracket, some code. And then we can put an else here, and another curly bracket, and another piece of code. And if we want to do something more elaborate, we can also do if something, 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 curly bracket, some code, else if. And then we can put like another else if. Oh, forgot that. And as many as we like. Sometimes we use another command called switch for this kind of thing, where we have a lot of different possibilities. So like we want to do one piece of code if a variable is maybe 1, and another piece of code if it's 2, and another if it's 3, and so on. Yeah. Goodie. So this word branching again is, I also used it about like loops, so while loops and for loops, and that's also a kind of branching, because the word branching just means that this normal order of operations where you just start at the top, work your way down, that is actually broken somehow. So the computer switches to another place in the code, and that all happens in all these 3 kinds of control statements, like if statements and while loop and for loops and stuff like that. So both conditionals and loops. They cause branching to happen. So a bit back now to Boolean expressions. Some more stuff you can do there. Call that logical operations. Logical operations. Logical operations are what we normally call and or not, that kind of thing. So we can take like two different Boolean values, and then we can, I mean, normally with numbers we can add them or multiply them and stuff like that. We can't do that with Boolean values, but we can do and or and not on them. So these three basic operations is mainly what we need. And I'll show you how to write these in processing or Java code. So two ampersands. So imagine A is a Boolean variable and B is also a Boolean variable. A and B, you should read. So this is only true if A and B are both true. Otherwise it will be false, this expression. And this is an expression. Remember that these double ampersands, that's like a symbol, and that's just the same as a plus sign or a multiplication sign. It's the same kind of thing. It's an operator. The next one is OR. We use this symbol. It's called maybe a pipe symbol, or I don't know what it's called in Danish. But it's like a very tall vertical line. That means OR, so this will be true if either A or B is true. If they both are true, it's also true. If they both are false, the result is false. True if either A or B or both are true. And the final one is not. So that's an exclamation point. You can see it better when the line is removed. So exclamation point and some Boolean variable, that means the opposite. So if it was true, this becomes false. If it was false, this becomes true. True if A is false. False if A is true. Yeah.
So operators like NAND and NOR would just be by combining the false and
Yeah.
okay.
Yeah. You don't have a NAND operator. So NAND is usually like a piece of electronics, but you can easily construct one by not and then something AND. So kind of put a little box around this. Slightly crooked. And just to just take these here and put on that slide as well, because you would often combine these, right? So these are also operators. It's a different kind of operator. They don't take Boolean values as input, but they give Boolean values output. So these take Boolean values both as input and output. So very often you would combine the two to create some Boolean expression to decide whether you should branch or not. Yeah. Okay, I'm going to stop the